what I'm going to talk about today is a highway survey. Unfortunately, I was hoping to say we finished, but we are still in the finishing phase. So there's almost every day there are some little issues to be still solved. But more or less we completed this survey. So just a few words about the company itself. So we established the company in 2015, mostly for photogrammetric surveys. So to do photogrammetric surveys of highway, railway infrastructure, both for the design stage, construction stage, and also for the after construction kind of inspection phases. So currently, probably last year, we surveyed more than 1,000 kilometers of highway. And as I said, trying not to be just only highway, but also railways, and we also occasionally do surveys of agricultural fields, but mostly the linear infrastructure is our key focus. And there was, like, since we are technology driven, we really wanted to go one step further, and we really understand the limitations of photogrammetry. So that's why we were trying to get in contact with a good LiDAR manufacturer, a good supplier, and I think we are very happy with the experience what we have with Yellowscan. So we are trying to utilize our investment as much as possible and maybe grow in the future. So the project itself, what we got commissioned to do middle of last year, it's called the M1 highway in Hungary. This is the highway which connects Budapest to Vienna, and it's one of the main corridors in Central Europe to get the traffic all the way from maybe Turkey up to Germany. And the thing is that, like, you can see, it's like just a picture of the road. Like, it's very, very congested. So the plan is to extend it from 2 lanes to 3+1 lane in both sides. And because there's a lot of traffic, it's not really possible to send manual surveyors on foot to inspect the present state of the highway. So it was kind of given that, like, we have to have a survey with like remote sensing. So it was a good use case. And what are also very special things that, like, we have to do everything in a very confined timeline. Like there's European Union money going into the reconstruction, so there are, like, very strict deadlines for both the design companies and also after that for the construction. So we had some, unfortunately the yellow is not showing up very nicely, but we had a preliminary plan to deliver the first, let's say, survey in January 2019, and then in, let's say, February, March timeframe, the final detailed survey of the whole area. It's 47 kilometers, so it's not just a tiny area, but it's a reasonably large amount of road. And there's two of the most famous and largest Hungarian highway design companies, design offices are there. And they used LiDAR before, mostly terrestrial scan and also airborne scan, but they have never, let's say, never used it for reconstruction. Mostly they used LiDAR for, like, a clean sheet greenfield design. And we had a good team together with some trusted subcontractors, and we took the job. Maybe I will just show a little video of how the area looks like. Okay, if you don't know where Hungary is, so middle of Central Europe. This is Budapest, highway connecting to Vienna, and you can see, like, this is kind of our flight plan. Let's put it this way. So we have mainly the highway itself. We have a lot of intersections. We also have a lot of water, rivers and streams, and we have to survey those. There are some important facilities like the highway offices, what we also have to do. and it goes next to a major road called number 1 in Hungary. So we have to also respect that areas, and you can see that like in some places it goes really close or inside some cities. So it was quite a project even when we started, and I'm going to tell you like how it actually grew and how it became a little larger than what we were expecting. So what we initially proposed is that like we will have a kind of a use case. So one highway intersection we will survey, we will show it to the design offices what LiDAR technology is capable of, and then we will assess what we should do. So with that, we also wanted to fine-tune the process, how to do the workflow. It's not just going out to the field, do one survey, but like we really have to plan in accordance to all the regulatory framework, and also in time-wise that how to kind of optimize all the workflow, not just only flight, but also processing and vectorizing the things. So what we said is first we should do a photogrammetric survey, and from those photogrammetric surveys we would vectorize the kind of 2D environment. So we have to have all the lanes on the roads and all the intersections and important features. And then, like extracting lines, also concrete structures and important things what have to be recorded before the design actually can start. And then we would do a LiDAR scan, and we would kind of give precise height to all the 2D features. And then that would be done in Topodot. And we initially knew that, like, of course, there's going to be certain features which are not really visible from the photogrammetric survey. So there are going to be canals and objects below vegetation, but we have to process purely from LiDAR. So that was kind of the initial workflow what we set up. And then, like, first thing is just to actually do the survey, do the flights. So you can see here the Hungary with its all airspaces. So the road goes somewhere here. We have to file all the paperwork 30 days in advance to be able to fly. So we kind of approximated that like it's going to take roughly 30 days to just do the pure survey. So that would mean that, like, if we run out of time and if the weather and if everything is not good, we just have to constantly renew or flight authorization and or restricted airspace. And yeah, the initial plan was to have 88 LiDAR flights, 40 meter height. We have 10 large and 22 small intersections in the area. And yeah, it's kind of a reasonable sized project for a couple of months. We also said that, like, okay, since the LiDAR precision is roughly around 5 centimeters, so there's no need for very low altitude photogrammetric survey, so like 4 to 5 centimeter resolution is okay. And we started to do all the data capture and everything, and we are using a DJI 600. We are having a base station always on site to be able to get, like, let's say, a redundancy in terms of GPS measurements, and we are also using the Hungarian GPS network. Funny thing is that, like, we found some problems with our surveyor, so Yellowscan was so supportive that they actually sent us a replacement unit, and we were able to conduct the survey, and we were very happy with all the customer service and all the support from the team. So then, next thing is processing. What is actually also tricky about the whole project is we are able to do, let's say, 5 to 10 flights per day, roughly 1 kilometer long section. So it's not just 100 by 100 meter, but 1 kilometer long, which is not so good for the uplink sensor, because, like, you are flying slow, and your Kalman filter is gonna start having, like, larger covariances, and your heading estimate is not going to be that good. So we have to try to do some tricks and assess the quality all the time. And then what is also bad is that like we have to get everything in the Hungarian national coordinate system, which is like it's derived from a GRS 1967 geoid, but it has a custom elevation correction grid. So like when we have the LAS files, then we have to crunch the whole thing and apply a custom correction grid to it, because like you can see that like in certain places there's like 25 centimeter height difference from the base geoid. And yeah, as I said, we use the Hungarian VRS network extensively, and then we gave the LAS and the photogrammetric TIFF files to our subcontractors, and then they produced DWG to the consortium. So as I said, we were in contact not just only with one highway design company, but actually two. And of course, they are not having the same specification. They are sometimes arguing with each other, so it's not that easy to match all the things what they would like. So initial delivery date was 15th of December, and then full detail 15th of January, and we are still supporting them, providing additional, let's say, additional support to them in case they find out that something is still missing from the survey. And so after we have the first set of flights, we learned what is the good pace, how can we actually set up our infrastructure on the field, and we also, it's very important in such a survey that like you actually get in good contact with the local authorities, that like, okay, if someone is coming to you and says that like, okay, you are not supposed to fly above the highway, and sometimes they are not just come to you and say, but maybe they are coming with a stick and try to just get you out of their way. So good connections. And then what we also figured out that like, okay, everything worked nice in theory with having the flight plan, but of course when you have wind, when you have all the restrictions, then the LAS files were not really overlapping nicely, so we actually had to go back and redo some of the overlap areas and also slightly adjust our flight plan. What was also nice, and thanks for Bart, we were like in contact with, let's say, UGCS and other related things. We were trying to troubleshoot some of the flight planning related tasks, and what was also interesting, and what is actually like, if you have a 1 month long period, then like in that period they actually started some reconstruction of the road surface itself. So sometimes the LiDAR and the RGB were taken in different times, and the road were like kind of in a different shape in those. So it's kind of tough. But like what is actually very important from this first set of flights, we started to develop a 35-page specification. What is like actually what we have to capture with vectorization and what has to be included in the final delivery to the customer. So even the language that like, okay, what are these lines, and like do they need the lower one or the higher one? Because like the design offices, these large companies, they have their internal kind of working mechanism, which is sometimes written, but sometimes it's just let's say custom, like how they do it. Like their own like their own surveyor knows what to capture, but because in the LiDAR and in the photogrammetry there's everything there, we don't know what is the exact important line or important feature for them. So we also started to develop this, like it's 35 pages, so it's not just a few sheets, and we have a couple of iterations about that like what it actually has to contain. And yeah, I already talked a little bit about it, but like long flight lines, 1 kilometer is kind of pushing the boundaries. So we also have problems often with loss of live station and loss of link with the UAV. So like when you have a 100,000 euro flying away from you and there's no telemetry, then you are kind of getting a little scared. And we were also very happy that Yellowscan was also very good partner in helping and evolving with us. So they actually started improving their own calibration process, and we also assessed the quality not just only on our own, but also with Julian a few times. And yeah, it was kind of a troubleshooting session in a sense that like we are actually in a big project, but not so many people did similar scale projects before, so we have to learn on the fly and adjust. And yeah, like one funny thing is that like when we processed everything and then we started to do quality checks, we find out that like, okay, VRS station versus our Leica base station gave like an 8 centimeter height difference. So we had to reprocess everything from scratch. And these are like slight things which like at the end of the day it would not be good if there would be an 8 centimeter difference, but we were able to, let's say, figure it out. So the thing is that like when we set off, we had some naive ideas, let's say, to what is actually required for the highway survey. And then also the design offices, they thought that, okay, we are going to be able to deliver what actually needed. But as we went into this whole process, they started to share with us like, okay, what they actually really need. And then we started to, let's say, see, okay, maybe LiDAR and photogrammetry on its own is not going to be enough. And of course, like when we started to talk only with the surveyors, they said, okay, it's going to be okay. But when we had all the teams from the road design, the water canal and water kind of designers, and the bridge designers, then new things started to pop up. So the specification what we developed, it started to grow. And also what was interesting that like this extension of the road, it's like the technology was not really clear. So as we developed and did our surveys, also they were refining their technology. So they were saying that like, oh, maybe could you get this also from the LiDAR scans? So it was kind of nice that we have all the raw data, and when they said, yeah, can you extract, for example, some of the benches in the let's say, in the gas stations, and we were saying, yeah, we have the data, so if you say, for extra money, we can also get more features from the scans. And what was also interesting is that, like, initially they were kind of saying, oh, there's no previously existing, let's say, surveys and no previously existing designs for these, just only for the bridges. But then we started to have data from the suppliers like the gas, water, telecommunication companies. So when we said, okay, this is a lamp or this is the post or a pole, then we were able to use these data to kind of put a sticker on each one of those that like, okay, this is telecommunication, this is electricity, and that was also something what we did not anticipate from the beginning, but it was actually good to gather more data and get more details and more refined things. Then we said, okay, for the bridges, like it was also like evolving with the specification, we have to do TLS scanning, not just only unmanned airborne laser scanning. So what was interesting is just only for the strategically important bridges, not for all, because some of the bridges are going to be demolished, so there's no need to survey those. But those which can remain, there's very important to see what is the like cross-section of these areas, and for those, the airborne laser scanner would not be precise enough. What was very nice is that like it was not a issue to stitch them together and work with them together. What the, let's say, the company who is doing the vectorization, they were used to terrestrial laser scanning, and of course you can see the difference between the thickness of the point cloud, so they have to adjust their working method when they were having only terrestrial or only airborne, and when we have the overlap in between those two, then they had to filter some of the points. it's just like everyone likes to see nice pictures. So like this is just a difference between the level of detail when you have TLS or when you have airborne. So this is like just TLS-based survey of one bridge, and this is airborne survey. So you can see a lot of the lines are kind of not that much certain. So we were using some symbols to show that, like, okay, some of the features are not as precise as with the TLS scan, but yeah. What was also important is we have to learn what is actually fully required for the highway design process. So rather than having gaps, so like in certain places you don't really have an idea what the LiDAR sees, so there's no gaps allowed in the process, and of course, like, we have to comply with the regulations or rules to go to the next step with the highway designers, that like they have their own software tools, and we have to kind of fine-tune like what kind of lines, what kind of points we can use, because like their software tools can just blow up if they are not specific line types or specific intersection of lines. What was also nice is that like we could also combine Google Street View images. So for example, late in the project, it came up that like, okay, if we have all the signs in the LiDAR scan and we have their placeholder, why not put the exact picture? So we could just combine then LiDAR, photogrammetry, Google Street View, and terrestrial laser scanning, and all the prior data. So then final delivery is something that like we have, as I said, 2 different companies, 6 different design groups. They all went through and like I think initially we have like a 55 item list of complaints from them, and then we just reworked everything, and now I think they are content. What is important to mention is that like traditional geodesy has much less points. So like when we vectorize a line, they have like maybe every 5 meters they have a point on the line. Here we have points every 5 centimeters or every 20 centimeters, so they can see that like, oh, the line looks like this, not a straight line in between 2 points, and then they start to say, okay, this is not good. So they also have to somehow let's say adjust their own working process, and I think they are very happy with what they see. They just have to change their mindset a bit. What they also have to understand is that like if we are like the vectorizing is kind of a sequential thing, that like you go like kilometer by kilometer. So if they say, oh, why not get the benches on the gas stations, then like you have to go all over again. So that actually is going to cost them money. It's not just like we were sitting on the meeting and they say, oh yeah, it's on the LiDAR scan, it's in the point cloud, so why not get it? And I'm like, come on, like if you don't tell me you need it, then it's not going to be extracted. And also what is very important for them is that like, because there are different disciplines, so there should not be any item which is called unknown, because then it kind of falls in between the benches or falls in between the horses, that like it's not going to be assigned either to the water, the road, or the bridge guys. And I think they were kind of very happy with the new technology, and they were accepting it in a nice way. Just some pictures about like what it's. I on purposely didn't put the LiDAR scan in the whole area, but also the forested areas were also a kind of afterthought, that like they would need the forest parts, and you can see all these placeholders of different infrastructure components, which are all labeled, and we know all the companies to contact in case we have to redesign those. And of course, what is also very important is that like there are certain places what neither the TLS nor the Yellowscan system is gonna survey. So a lot of these waterways have to be manually surveyed, and you have to go to the field and inspect. And it's like the LiDAR scan is very good. You can see, visualize, but still you have to go to the field and see for your own, because like in some cases these waterways, like they have some cracks inside, so there's no way to inspect that with any kind of automated remote sensing application. Probably my time is running out, so just a few pictures. So like what you have is that like all the lines and all the supporting infrastructure vectorized, and what you see here also that like how nicely the LiDAR getting out of the tool chain and the photogrammetry getting out of the tool chain, and the corresponding vector features are aligned nicely. And that's a key, that like you need really good match in between the photogrammetry and the LiDAR scans. And of course we did not put photogrammetry equipment onto the LiDAR equipped drone, but we performed them separate times with like fixed wing vehicles on the photogrammetry, because it would be just much more, let's say, much more risky to have too much payload on the system. I think maybe these are just the little pictures of like the same bridge. Like this is a cross section of a bridge with airborne and TLS scans. This is the same bridge, but from another cross section. So what you see here is the road surface, what you see from above, and then the TLS scan from inside the bridge itself. And this is the same bridge, just TLS and LiDAR combined. So you can see that like what you don't see underneath with the airborne scan. So you can very nicely put these two things together, and it was kind of nice. What was also tricky is to combine all these techniques and combine and know what to do when and how, and also handle the high vegetation areas when even the surveyor was not able to penetrate. So you have to assess all the quality of the data and then go there and manually get the points. And water is also problematic sometimes, that like you don't have too much reflection. And also we have a lot of concrete. We have a lot of asphalt. Asphalt has pretty bad reflection, and you also have to distinguish in vectorization like what is actually concrete, what is asphalt, and how to. You have to be able to get different labels to those. And this is what I was talking about, that like sometimes if your flight plan is not perfect, then you would have a little gap in between those two. And also when you have 1 kilometer long flight lines, you have to beef up your DJI controller a little bit to have sufficient range. And even with that, sometimes you actually end up on the top of a tree. So like we are using a GoPro to like have a first-person view, because like sometimes like the terrain elevation is such demanding that like you are able to see, but you don't see what it actually starts to hit. So in one occasion, not in this project, but in a different project, we ended up on the top of a tree. So that's not so good. And sometimes we encountered military helicopters during the survey. So that's also not so nice when you have a restricted airspace and the military helicopter just crosses in front of you, and maybe your drone is somewhere here and you are kind of afraid that it's going to hit. But what I wanted to say is that like you really have to harmonize the expectations of your customer with the reality. So we have to be transparent. What are the weaknesses and limits of the LiDAR, and we also have to provide the feedback that like, okay, if you need more, that will cost you more, and not everything just pops out automatically from the survey. And you really have to learn the legacy tools of your customers, and always have to prepare for iterations. And you have to be really proactive. So like what you can fly today, do not leave for tomorrow, because tomorrow the weather is going to be bad. Your man will get sick. So yeah. So how we would start now? We would get all the possible data what we can obtain prior to the survey, and really push the customer to give us those what they were withholding. We have to get much more detailed with the price quote. There's a typo there, but as I said, I explained that like a lot of things just popped up after we started the survey, and like they and us all learned our lessons there. And first we would do just really manual inspection and RGB, and go through detail by detail which are the problematic areas, and then do the tricky parts, manual survey, and then do the LiDAR scan afterwards. So I think that's what is the key takeaway from this, that there's going to be like the LiDAR is the more time-consuming, more costly, so I would leave that to the end, and I would know what areas are the tricky ones. So just to give you an idea, like this is also like the highway, and there are like some steep hills around there, and of course there's some towers, so it's always good to know what to expect. So in conclusion, we signed up for a challenging flight task, but we ended up doing a much more detailed and rigorous experience, not just only flying, but collecting ground data and terrestrial laser scan. I was very happy with the support from Yellowscan, and also support from our customers. They were very happy with what they have seen. And what is also a very important lesson, that like the traditional surveyors do not want to go out on a highway and risk their lives, because they can get hit by a car. So what we are actually very proud that we finished this, and we are looking for the next challenges, similar projects in Europe. So thank you very much for the attention.